Assalamu alaikum everyone, welcome to the third lecture of the antenna designing tutorial series featured by BRBD. Throughout the series, I am Tufail Kareem is serving as an instructor, Muhammad Ashraful Haq sir is there as a mentor, and the whole series is coordinated by Sabir Hussain sir. So far, I have covered the theoretical aspects of antenna designing. In today's lecture, I am going to demonstrate the designing procedure of a 2.4 GHz patch antenna on the CST software. In the previous lecture, I have discussed that to effectively design an antenna, we need to select a proper substrate material and pick up an operating frequency. After selecting these things, we are ready to design our antenna. To design a patch antenna, first we have to calculate the patch dimensions. The formulas to calculate patch dimensions were demonstrated in the second lecture. In this lecture, I will show how to calculate the dimension using an online antenna calculator. Go to your web browser and search Microstrip patch antenna calculator. Now click on the first one. Here the calculator needs some value to calculate the patch dimensions. We are going to use an FR4 substrate of thickness 1.5 mm and the dielectric constant of FR4 is 4.3. So the dielectric constant is 4.3, the dielectric height is 1.5, change the dimension into millimeter, and the operating frequency is 2.4 GHz. Now click on the calculate button. Here you go, the results are width 38.37 mm and length 29.79 mm. If you scroll down the page, you can see a picture of the patch that clearly identifies the patch width and length. Let's explore CST Studio Suite to design our antenna. Click on the Create New Project. There are 5 different modules of CST, among which we are going to select microwave and RF and optical module. Click Next. Then select the planar workflow and click Next. Normally, time domain solver is used to assess patch antenna performance. Click Next. Here we will set the unit, the dimensions are in millimeter and frequency is in the gigahertz unit. Click Next. Here, as our antenna will operate on 2.4 GHz, a frequency range from 2 to 3 GHz is okay. Besides, we will select some field monitors like electric field, H field and far field monitor at 2, 2.4 and 3 GHz. Click Next. Now give a name to the template so that we can use this template again for another design. This is the workplace of CST where we will design our antenna. First, enable the local coordinate system by clicking on local WCS. We will start our design by creating the substrate, select brick and press the escape button. Now name it as substrate. Here U is the horizontal coordinate and the substrate width will be along the U axis. Half of the width is along the negative U axis and half of the width is along the positive U axis. Let's set the substrate width as SW, the length as SL and the height as H. U minimum is the negative part of U axis and U maximum is the positive part of U axis. Set U minimum minus SW by 2. The negative sign indicates the negative portion of U. U maximum SW by 2. Similarly, V minimum is minus SL by 2 and V maximum is SL by 2. W axis represents the height of the substrate, W minimum is 0 and W maximum is H. We will select the FR4 material from the material library. click on preview and define the variable to see the structure. Click OK to finish the process. To create the patch, click F and select the upper face of the substrate. Now click on Align WCS to align the local coordinate with the selected face. Select brick, press the escape button, give it a name like a patch. Again, the U-axis denotes the patch width, hence U minimum minus AW by 2, U maximum AW by 2, V minimum minus AL by 2, V maximum AL by 2. Along the W axis, the patch thickness. So W minimum is 0 and W maximum AT. The material is copper. Click on preview and define the variables. Click OK to finish and create the patch over the substrate. To create the feed line, let's move the local coordinate system to the edge of the patch. Click on local WCS, go to the properties and set the Y value minus AL by 2 to move the coordinate system along the negative side of Y axis. Click preview to see the location, click OK to continue. To determine the feed width for impedance matching, go to the home menu, then macros, click on calculate and then calculate the analytical line impedance. From the setup option, select thin microstrip. The frequency is 2.4 GHz. Substrate height is 1.5 and permittivity is 4.3. Now suppose the width is 3.1, click on calculate and the impedance is 48.42 ohm. We need to set it at 50 ohm. Pick another value, for instance 2.9, and the impedance is now 50.42. Keep iterating to have a value that is too close to 50 ohm. At 2.94 mm, the impedance is 50.01, which is almost 50 ohm. Exit the panel, go to modeling and select brick. Name it as feed line. U minimum is minus FW by 2. U maximum is FW by 2. The feed line will extend towards the negative V axis. So V minimum is the feed line length, which is half of the substrate length minus half of the patch length. SL by 2 minus AL by 2. And V maximum is 0. The height is the same as the patch height and it is AT. The material is copper. Click on the preview and then click OK. It's time to make the inset. To create the inset, move the local coordinate system to the positive edge of the feed line width by inserting the value of x as fw/2. Select brick and give it a name inset slot. The inset will extend along the positive u-axis, so u minimum is 0 and u maximum is IW, which is inset width. Again, the length of the inset will be solely along the positive v-axis, hence v minimum is 0 and v maximum is IL, length of the inset. And the height of the inset is identical to the height of the patch AT. The material is vacuum. Click on the preview to check the inset slot and click on OK to finish the design. Select cut away the highlighted slot. A slot is generated. Now, move the local coordinate system to the negative edge of the feed line by inserting the value of x as -fw/2. Repeat the similar process as inset 1 and create the second inset. The only exception is that the inset width is along the negative u-axis, so u minimum is -IW and v maximum is 0. We are done. Now select the back face of the substrate by clicking F and click on Align WCS to align the coordinate with the selected face. Now, again, select the face by clicking F, select the extrude face, name it ground GND and give the height similar to the height of the patch AT. The material is copper. Click on preview and click OK. As you can see, the ground is created. You can see that the patch and the feed line are separate. Sometimes it is better to combine them. To combine, select the patch, click on Boolean addition, select the feed line and now click enter. Both shapes are successfully combined. Now the waveguide port is required to excite the antenna. To create the waveguide port, zoom in the design along the edge of the feed line. Select the thickness of the feed line by clicking F. Then go to Home, Macros, Solver, Ports, then calculate port extension coefficient. A dialog box is open. You can see that it has already taken the required dimensions. All you need to do is click on the calculate button and then click on the construct port from the selected face button. Done, your port is created. Finally, it's time to simulate your design. Go to Simulation, the Setup Solver, leave everything as it is, just set the impedance to 50 ohm and click Start. As you can see, the simulation is running. Go to 1D results, then S parameters to see the S parameter of the designed antenna. The S parameter gives you an initial guess on whether your antenna is radiating or not. It is seen that the antenna is radiating in the frequency ranging from 2.31 to 2.38 GHz. Although we aimed to operate the antenna at 2.4 GHz, it is operating at the frequency of 2.34 GHz. You can also explore other parameters like VSWR, radiation efficiency, etc. Under the 2D results section, you can also explore the far-field pattern of your antenna at your desired frequency, where you can check the directivity, gain, etc. Although we calculated the antenna dimensions for operating at 2.4 GHz, it seems to operate at 2.34 GHz. That's why we need to further optimize the antenna dimensions to make it operate at 2.4 GHz. In our next video, we will demonstrate the optimization of antenna dimensions on CST. Till then, stay tuned.